All right, short section, section 5.3. This is all about the rules for definite integrals, all right, and some theorems. Okay, one of the theorems we already talked about, but here come the rules. Okay, your first set of rules, number one, this is probably really the biggest one here, order of integration. Okay, the big thing about this is that if you always want the smallest number on the bottom and the biggest number on top. And if you flip them, it's the inverse of each other. For instance, okay, if I had the integral of negative 2 to 4, which is perfectly fine, dx. All right, and I would say that that could be the same thing as saying negative integral from 4 to negative 2 f of x dx. Okay, that is always true. Okay, order makes a difference. It should always be smallest to biggest. Smallest to biggest. When it's biggest to smallest, you flip them and make a negative. Okay. Other one is 0. If I have an integral that goes from the same number to the same number, it's going to be 0 every single time, because you got to think about that. What's the area underneath the curve from one number to to the same number? Nothing. Okay. Constant multiple. All it's saying is if I have some constant I can factor out of my entire function, I can pull that factor k out. Again, k, that's a number. Okay, it is not a variable. Sum and difference. Okay, so if I've got different functions I can pull apart that are being added or subtracted, it's just like I can take the integral of one and do the integral of the other one. Yeah, that's easy enough. Finally, the additive one, much like our summation rules, if I'm going from A to B and the next one goes from B to C, well, by gosh, I can be able to put them all together and go from A to C. Okay, next question, or next set of rules, is the min and max inequality. Okay, so when they say min of f, okay, so let's pretend I have a function here. And I'm going to call this here as my f of x. I'm going to go like this as well. And so what it's saying is that here is A, here's B. Is that min of f is the smallest value of f on the interval. Okay, max of f is the largest value of f on the interval. So there we go, smallest. So here it says here's my min of f times b minus a. Boom. There's that area. And then I have max of f, which is this big thing right over here, will be this whole area. And then my actual integral value, because this is also here, my actual integral value is this stuff in between here. So when I look at this, hopefully you're able to see that the minimum value 1 is less than the maximum 1, which is the real one is in between. That's all it's saying. That's what this is saying, and that will always be true. And then, of course, we have our mean value theorem, which we talked about just yesterday and discovered. That is, if I want to find the average value of a function, okay, that I would go ahead and find the area and sum up all the area underneath and divide it by the interval. Okay, next. So now I'm going to take a look at some of these problems, and here we go. So it says here they give us a specific thing. They say from 0 to 1.25 cosine of x squared is 0.98. And from the integral from 0 to 1 of cosine x squared is 0.9. They want us to find the following integrals. So I'm going to do the first one, and then I am going to do the second one. I'll see what you do, come up with the third one. We'll find out here. So first one. So I'm going from 1 to 1.25. So I'm just going this little distance here. I want to find that little amount of area right there. Well, they tell me from 0 to 1.25 and from 0 to 1. So I can come up with the idea that the integral from 0 to 1 of f of x plus the integral from 1 to 1.25 of f of x is equal to the integral from 0 to 1.25 of f of x. And that's just like, that's one of my properties, right? Well, now look what I can do. I can plug in what I want and find out what I want. I plug in, 0.90. I plug in over here the 0.98. Subtract to find out this is 0.08. For part B, they want this part here, from -1 to 1. Alright. So, I can see that this is an even function, and I can see that the 0 to 1 is going to happen twice. So it's just going to be twice this, the 0.9. And this one's 0.9. So this one's going to be 1.8. So now what I want you to do is I want you to figure out for part C. I'm going to pause the video and we'll see what you guys get. Alright. Ta-da! Here's your answer. -1.88. How did I get that? Okay. The big trick here is, look, this right here is not settled, right? This is not smallest to biggest, so I need to make it smallest to biggest, but when I do that, it becomes a negative on the outside. I come down here and change this. Well, I'm going to break this up from -1 to 0 to 0 to 1.25. I found out what that was, the -1 to 0 in part B as being 0.9. 0 to 0.25, I got that, that was given to me as 0.98. I add the 2 up and put a negative on the outside. Okay, let's go next, see what we got next. Okay, so in general, if I have an even function, this is kind of a big thing to have, and you guys saw a little bit this in 5.2. I'm sorry, I gotta make this bigger so everyone can see it. Okay, is that if you have an even function, okay, the integral from a negative number to the positive same version of the number is just 2 times the integral from 0 to there. So what it's saying is whatever integral for this whole thing, is twice from 0 to a. And vice versa, if it's an odd function, then if I'm going from -a to a, it will always be 0. Okay, so I'm going to shrink this back up and say, well, what can I do for sine of t and absolute value of sine of t? So when I graph sine, here's sine. Okay, there's my sine. Which you should notice it's an odd function, right? And so if I'm going from -pi to pi for an odd function, this for part A will always equal 0. Okay. For part B, now it's saying the absolute value. Well, if it's the absolute value, it means everything is positive, which means this is what I have here. So if I have that, then what's going to happen is I've got two. Now it's like an even function. So if it's an even function, it's twice of what I had. Well, they're telling me from 0 to pi, it's 2, so therefore my answer is 4. Okay. Hopefully you're picking this up as we go along. So, all right, now this one's an interesting problem because it sits down here and tells me the graph of the derivative of f prime is shown in the figure below. Fill in the table of values for f, okay, given that f of 0 is equal to 2. So we had talked about how multiplying a derivative, not a derivative, but multiplying a rate times time or whatever gets me my distance traveled. Okay? It's my displacement. That's kind of how we talked about it. So if you will, think of f prime of x. Let's think of that as v of t, my velocity. So when I figure out this right here, I can say, well, I went backwards, right? Because my velocity is negative by a half a unit. So how does that affect where my position was at? If I started at 2, but I know I went backwards a half a unit, then this needs to be now 1.5. And then in the next second, I went backwards because this is negative, right? Below the x-axis, I went backwards another 1. I went backwards 1. So this is going to be, so I subtract 1, I go backwards 1. Then I go backwards another 1. That's that one there, negative 1.5. And then I go backwards another half. It goes to a negative 1. I'm going to pause the video again here, and I want you to do the next 2. Okay? I want to see what you guys get. Bam, there's your answer. Okay? This time I was going forward. I went forward a half. So I was at negative 1. I went forward a half. I was at negative 0.5. I went forward a half. It's an interesting concept and how these are relating. We'll get more into this later. I thought this was an interesting problem. I would want to go ahead and share it with you. Okay? So next couple of things here. They say let integral from 0 to 3 of f of x equals 6. What is the average value of the function on that same interval? Okay? Remember to find the average value. It's 1 over my b minus a, so 3 minus 0, okay, equals, not equals, but to the integral 0 to 3 f of x dx, which is equal to 1/3 of 6, which is 2. Okay. Now we're going to bring that whole conversation we had in there about even and odd functions for this next one. Okay. So these next 2, I want us to consider if it's even or if it's odd. So remember the conversation we had? I want you to go ahead and take a look at these 2 problems, B and C, and figure them out for yourself and see if your answers match mine. Bam, there it is. So when I take a look at this, one of the big things you got to remember is, hey, for the even function, okay, if I'm going from negative a to a, which is what's happening here, it's going to be twice the amount from 0 to that a. So that's why this is 12. Okay, and if it's an odd function, my integral value is going to be 0. So those are your 2 answers. Okay, here you are. This is from number 11 in your book. I said use a calculator to find the average value of the function on the interval given. At what points does the interval assume its average value? So I'm going to show you how to do this on your calculator. Here we go real quick. So here's your calculator. Okay, so I got your calculator up. I already put into y1 x squared minus 1. I'm going to go, I want to first find the average value from 0 to the square root of 3. So my average value, okay, is going to be 1 divided by square root of 3 minus 0. So in this case, just square root of 3. Alright, times, now the integral, so math 9. Okay, between 0 and the square root of 3. My function is going to be y1. So under vars function y1 with respect to x. And I hit enter. Huh. And again, this is kind of where you need to be a little bit smarter than what the calculator is telling you. So if I sit down there and say, wow, that's the value, and then you have to realize, what is the e to the negative 14? So you go back to science class real fast, right? And that's saying, well, that's like 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 2, 3, 5. That's a lot of zeros. And so what you're saying is your calculator is like, ooh, that's, your calculator is, it can't be that precise all the time. So when you see something like this, okay, it's 0. So my answer is 0 for this. That means the average value for that is 0. So at what point in the interval does the function assume its average value? Well, how can I find that in my calculator? So I'm going to go back here to my calculator. I know its average value is 0, so I can go back here to y equals. I can go ahead and put in y2 is 0, because that's the average value. And I'm going to go ahead and hit my graph button. So there's my graph. And I graph the other one. It's all done. And I'm going to find out, well, where is this going to equal that? Hopefully you're able to see that if I go zoom, because it wasn't right, zoom 6. That's what you should probably look at. Okay. It's going to, where does it achieve it? Hopefully you can see this going to be at plus or minus 1 is where that's going to happen. And so that's where it happens here. That's what your answer is going to be. So you can say the average value of x squared minus 1 on that interval is 0. Not theta, 0. F of x is 0 at x equals negative 1 and 1. Those are the types, that's what you're going to have to be doing on the other problems that you'll have like that, okay? And so for your final answer, there's your book section, 5.3, 1 to 6, and 12 through 15. Hope everything worked out for you. We'll talk with you guys later, and good luck.